Good afternoon. This is the automatic cheese roll-up maker demonstration video. This is a San Jose State College of Engineering ME 106 and 154 joint project. Now, what we've created is an automated cheese roll maker, which, if you don't know what a cheese roll maker is, or a cheese roll-up, it's a product from Taco Bell. And so it's actually what it is a tortilla with cheese on it that is placed in the steamer, steamed, heated up, and then rolled up and served to customers. Well, we thought we could come up with a better and more efficient way of doing that. So what we've created here is the automatic cheese roll maker. We use two Moog-Animatics smart motors, servos. These are integrated servo systems, and they're powered by a 42-volt, 20-amp linear power supply. And they actually feature a built-in microprocessor in each motor. So we are able to skip using an external microprocessor, and instead they actually run the whole show for the whole machine. Housed within the mechanism is actually a heat source that we're using. It's actually a clothes iron. It's a 1,000 watt clothes iron, and it provides both heat and steam. And the overall machine uses a 4-bar linkage system. The linkages measure 5 inches for the ground link and the bottom link, and 9 inches for both of the other linkages, with a 2-bar driver diode, making a full 6-bar system. For a user interface, we actually use a 2 by 16 line, or 2-line by 16 column LCD display, which is driven or commanded by the master smart motor, which is mounted to the driver diode, and with an intermediary MAX 232 adapter chip, which is housed inside of this box. This display will tell the user some of what to do, and also the progress of the cooking. We have 3 push buttons here. They're not labeled yet, but the top button is an OK button. The middle button is the plus button, and the lowest button is the minus button. Now these will change. You can use the plus or minus buttons to change some of the settings within the system. So you can tailor your cheese roll, the kind of the meltedness of the cheese, to however you want it to be. Furthermore, since you can adjust the temperature, it's actually the temperature setting that you can adjust for the heat of the cheese roll-up. We use an LM35 IC temperature sensor, which is housed inside the heat source, inside the heat shield up here. And it actually goes down through the center, and it measures the temperature of the chamber during cooking. So we'll go ahead and demonstrate this. Now this is going to be a dry run, meaning we have the water bottle and everything hooked up, but we're not going to be putting water for steam into this, but the heat source is on. So as you can see, we're already set up. It says the display says press OK button to continue, so we'll go ahead and press this. In which case, as you can see, it raises up the heating element and gives us room to put our tortilla in. We're also not going to be putting cheese on this right now. This is just for demonstrational purposes only. So you go ahead and you put your cheese roll up inside here, and you hold it between these 2 tongs. These tongs will hold the cheese roll up during cooking, and they're attached to the slave smart motor back here. And when the full cooking is done, this will actually serve to roll up the cheese roll for the final product. So we have this hooked up there. We're going to go ahead and change our desired temperature. Default is 30 degrees Celsius. It's kind of a room temperature thing. Just for quick testing here, we're going to raise this to 40 degrees Celsius. Like I said before, this temperature is actually monitored by the LM35 chip that is housed inside this heat shield. So we're going to go ahead and set it to 40 degrees C. We're going to press the OK button again. It'll now lower the cooking platform over the tortilla and the cheese during testing, and it'll now cook. And as you can watch, it'll show you the temperatures, your actual temperature and your temperature set point. So you can see the current temperature is 36, temperature set point is 40, which is what we set it at. So once it becomes over 40, it'll then raise up the heat shield like that, and it'll then roll up the cheese roll up. So once it's done rolling up, it gives you kind of a wait command here. It lets the user press OK when they're ready to start the next cheese roll up, but you just go ahead and squeeze these 2 here, pull the cheese roll up, and the cheese roll up's done. With this machine here, it uses two Moog-Animatics smart motors. We bypass the Arduino completely, which is this motor right here, and a slave motor in the back. The master motor controls both the display, all the buttons, the temperature. It reads the analog input from the temperature sensor. It's an LM35 temperature sensor for reference, and it also controls the slave motor in the back.
Right. Can you demonstrate?
You go ahead and demonstrate. So you just pretty much follow the on-screen instructions. When you first plug it in, it has a little homing sequence it does, but nothing special. So we'll go ahead and press the OK button to continue. So it lifts up our heat source here. And inside this chamber is actually a clothes iron, fully dismantled. So that provides heat and steam.
Okay.
So we'll go ahead and put the tortilla inside the holder. Some cheese. Nice distribution of cheese across the whole tortilla here.
Oh man, my stomach is going gurgling.
And so you can adjust the temperature that you want the food to reach using the up or down buttons. Yep. But it automatically defaults at 30. 30 is the minimum, in which case if you leave it at 30, it will just lower this down and lift it right back up. But we'll go ahead. We've been using 60 today. It seems to be a good temperature for this. Go ahead and hit the OK button. It'll lower down the platform.
You don't have to dump it. I'm just going to put it in the back of the truck anyway.
And so now you'll see on the display here, it'll show that it's now cooking. AT is your actual temperature, 30 degrees C. TSP is your temperature set point of 60, that's what we said earlier. So for this part, it's still a manual part. We didn't work in a water regulator because the water regulator that's built into the iron we actually disabled when we took it apart. So we just kind of feed this guy some water.
I mean, unless you actually have a need for a rate.
At 37.
Yeah, and we use a LM35 temperature sensor IC in the heat chamber. Initially, they had it down actually on the backside, but tucked underneath. And what was happening was because of the steam and the heat, it was actually the condensation was messing up the temperature readings. You'd actually come up with like a negative temperature. I think I was having a short out in there.
At 43.
I think it's just because I realized like how much more work we need to do for it.
This one's gonna be perfect. I think it's perfect, guys.
47.
Did you say you wanted this one? Comes like that?
Yeah, we'll get the motor and the lead screw back to the later.
Yeah, just leave this.
Some of the dimensions we don't have anything to decouple.
Well, I don't have a full bottle of water. It's a bit easier.
55.
This is the whole platform of this.
6 foot up. And we have some melt. Yes, and it's rolling.
Actually, you want to read a card over? Yeah, I can bring my card over.
Oh yeah.
Cheese roll. You want this one?
Oh yeah, all right.
It's melty too.